Hello everybody, my name is Thomas Beyer. I'm with a team called QIMP, Quantitative Imaging and Medical Physics. We're based in Vienna. Our team is made of a number of people with all different backgrounds and all nationalities. We have in common that we are very enthusiastic about science and clinical applications. Our vision is to gain expertise and share knowledge in a cross-specialty engagement. In the end, we want to make every photon count. And I'll tell you what that means. Photons are used frequently in medicine. They can be used as part of tomographic imaging modalities, meaning transmission imaging or emission imaging. In the case of emission imaging, when these photons are emitted from the body, we speak of nuclear medicine imaging technologies. These photons can be produced directly or indirectly through radioactive decay. The idea of these detection of these photons is that we are able to label biomolecules that are injected into the human body. And by having these labeled biomolecules with a little positron emitter or emitter of photons attached to it, we can actually non-invasively probe the molecular pathways and signaling pathways in this human being. Once these molecules are distributed throughout the body, their signal is being picked up through the detection of these photons. This can be done with singular detectors or with multiple detectors. If we acquire these photons in a tomographic fashion, for example, we can create a series of tomographic images that represent the non-invasive assessment of molecular pathways. This information can also be quantified. The downside of nuclear medicine imaging is that we suffer from a rather poor resolution. Also, these images, although they provide highly specific information about the accumulation of these tracers, they give away very little morphological imaging. And that's why people have started to invest into the development of so-called hybrid imaging modalities, also referred to as anatometabolic imaging. And the idea is that these photon accumulations or tracer accumulations, for example, in the heart or in tumors such as in the liver, are being interpreted in an anatomical context which is provided through the conjoined or complementary measurement of a computer tomography or magnetic resonance imaging scan. And these modalities or these hybrid imaging modalities come in three flavors. For example, the combination of PET-CT, a combination of PET and MRI, or a combination of SPECT and CT. At least these three are available for routine clinical imaging and have been around for about a decade or so. Today, we have about 5,000 to 7,000 of these imaging modalities available worldwide. Our ambition as a research group, as QIMP, is to go beyond simple image fusion in hybrid imaging. We want to help make synergistic use of the information provided in hybrid imaging exams. As such, because this pertains to cross-specialty engagement, we cannot work on our own. And therefore, QIMP is really embedded in a larger center that is called Center for Medical Physics and Biomedical Engineering, which is a large institute that encompasses about 110 to 120 people working in various aspects of medical physics and biomedical engineering. As part of this center, we are part of the Medical University of Vienna, a fairly young university founded about 13 years ago, coming out of the University of Vienna. By being anchored in the Medical University of Vienna, we are being provided with a network of clinical experts with who we can toss our ideas, get our innovation from, and help to respond together to clinical questions set forth by patient management today. I think this is a really exciting area to be in. It's a wonderful working environment, and I wonder if you'd like to join us in Vienna.